We are now going to prove compound angle formula, formula 9, which states that tan of A plus B is equal to tan of A plus tan of B divided by 1 minus tan of A tan of B. So we're going to start with the definition of tan, which is given to us on page 13 of our formula book. So these are the definitions given on page 13, and this is tan. And it states that tan of A is equal to sine of A divided by cos of A. So using that, tan of A plus B must be equal to sine of A plus B divided by cos of A plus B. So anywhere that you see an A, I've just added on a B. So sine of A plus B divided by cos of A plus B. And the reason I've done that is because we're interested in tan of A plus B, not just tan of A. Then we're also going to use formula 5 of our compound angle formulae, which states that cos of A plus B is equal to cos of A cos of B minus sine of A sine of B. So our denominator, cos of A plus B, now becomes cos of A cos of B minus sine of A sine of B. So cos of A cos of B minus sine of A sine of B. And we're also going to use formula 7 from our compound angle formulae, which states that sine of A plus B is equal to sine of A cos of B plus cos of A sine of B. So our numerator, which was sine of A plus B, is now sine of A cos of B plus cos of A sine of B. So now this is what we have equal to tan of A plus B. So next we're going to divide above and below by cos of A cos of B. So we're going to have sine of A cos of B divided by cos of A cos of B plus cos of A sine of B divided by cos of A cos of B. And that's all going to be divided by cos of A cos of B divided by cos of A cos of B. Bring down the minus. Sine of A sine of B divided by cos of A cos of B. So now we have 1, 2, 3, 4 fractions contained inside of one fraction. And each of those smaller fractions have a denominator of cos of A cos of B. So now we can start to simplify. So taking the first fraction on the top left, we have sine of A cos of B divided by cos of A cos of B. Well, the two cos of B's will cancel, leaving us with sine of A cos of A, which from our definition tells us is equal to tan of A. So this becomes tan of A. Then we bring down the plus. This is the next fraction that we're going to simplify, which states that cos of A sine of B divided by cos of A cos of B. So now we can cancel out the cos of A's, leaving us with sine of B divided by cos of B. And again, that is equal to tan of A, or in this case it's tan of B, because there are B's in our formula, but we go by this definition. We bring down our dividing line, and the next little fraction we have is cos of A cos of B divided by cos of A cos of B. So they just cancel each other out completely, and we're just left with 1. We bring down the minus, and next we have sine of A sine of B divided by cos of A cos of B. And again, using our tan of A definition, the sine of A divided by cos of A will give us tan of A, and that's stuck on to tan of B, which we get from sine of B cos of B, again using this definition. So ultimately tan of A plus B is equal to tan of A plus tan of B divided by 1 minus tan of A tan of B, and that is formula 9 in our compound angle formulae.